Thank you very much for being here and for your remark about contaminants, because they stick to the sediment. And that's important to know because it's also a leading thing in my story. I'm Tito Vellinga. I'm working for the Port of Rotterdam Authority for over 36 years and Delft University of Technology for 11 years. I'm a professor of ports and waterways. I'm very proud of João and Caroline because they graduated with honor last year in my department. And even more proud that they organized this today. So thank you very much. You're great. This will be about contaminated sediment, the management, but it's more about things behind it. I want to inspire you with the kind of thinking we started in the 80s and the 90s. It was just new thinking beyond legislation, doing things that we didn't normally do. And I hope to get that across during this presentation. This is the Port of Rotterdam. There is the Erasmus Bridge, which is a beautiful landmark in the city of Rotterdam, crossing the one branch of the River Rhine. We call it the Meuse, Old Meuse, but it's the Rhine. Then we have our office here, and I'm somewhere in this office in my daily life. You see containers are being transported upstream. They go to the hinterland, which is Germany, France, Switzerland, 700 kilometers upstream of the Port of Rotterdam. And the river brings a lot of prosperity, but also in the past, certainly in the past, brought a lot of problems as well with contaminated sediments. With all our clients upstream, steel industry, chemical industry, pharmaceutical industry, they also caused us some problems. And that's the main thing I want to deal with today. Historical view, in the 70s, there was an increasing problem getting rid of contaminated sediment. We had 20 million cubic meters to deal with, more or less, half of it contaminated. We had disposal sites in fields of farmers, but there was increasingly pressure against doing that. There was regulation introduced. We did research on new methodologies. And in the early 80s, we made a strategic plan. And the plan was primarily source control. So not find a solution for contaminated sediment, but source control. And we had an intermediate solution in a huge disposal site. I think it's the largest in the world, the Slufter. To solve the problem for the intermediate time, and for the time until we had solved the problem completely by making the sediments clean. And I remember I started working in the end of the 70s. I had to go as a young engineer from Port of Rotterdam to a neighboring community. And there was this sand mining pond. And it was very deep, and it was an ideal place to put in dredge material. And the neighboring community was also where a lot of agriculture was being done in greenhouses, and they grew tomatoes. And I remember that evening, I was thrown at with tomatoes by angry people. They said, we don't want this in our backyard. So that as a young engineer, you really get startled and you start thinking, is that what I want to sell? I only want to sell things and explain things which are sustainable. And maybe it could be sustainable, but when people don't want it, I should realize, do I want it? That's what changed in me, my thinking as well. Going towards the sources. Of course, we had the dredge material to manage. We have an extensive program still today in Port of Rotterdam. It starts to know what you talk about, to monitor, classify. It's not all the same. We do maintenance dredging, enormous amounts, 24 hours a day to keep the port in its depth. We do sustainable relocation. We bring the sediment where it belongs. If there would not be a port, the sediment, most of it would go towards the sea to contribute to the wetlands and intertidal areas. We do confined disposal, but we did very much in source control. Monitoring classifications, we do it together with the ministry. They manage the river, we manage the port. These are our substances. They're well known. TBT is the last one. It's used to paint the ships. It's a difficult one, but all of them are strict programs also in law to ban them out. But those are the chemicals that we test for. We do annual sampling. We have in Port of Rotterdam, these are some port basins. We have 250 basin sections. We sample at 6 locations. We make combined mixed samples and analyze. And then we find degree of contamination. Then we compare it with the list which is allowed. This is the list, what is allowed to dispose offshore into the sea. That's the most strict regulation, you can imagine. I will not go into the details. They are in my presentation. When we look at the port, we have sediment coming from both directions. Most of it comes from the seaside due to the tidal activity in the port. So most of it comes from the North Sea into the port, and then we have the river part. This is 100% river. This is about 50% from the river and the sea. This is 90 to 95% marine sediment. You can imagine the marine sediment is relatively clean. It can be disposed back into the marine system, but you have to test it. When we look at the classification, this is a little earlier than today. We classify according to what can be disposed back into the marine system, which is the blue, and the yellow has to go to the confined disposal site. So it's above the levels for sea disposal. And the yellow is disappearing and the blue is increasing. A little bit about maintenance, dredging. You explained about it. We have our dredging, trailing suction hopper dredgers moving throughout the port 24 hours a day. Maybe this is a nice one for you, Renee. It's a very old-fashioned one, but very effective. It's when you go to the quay walls, you lower it and you pull it away from the walls. It's a silt rake. We do most of it by now is clean. We can relocate it offshore into the sea. Transport distance optimization. When you bring it close to the port, the marine currents will bring it back in the port. So the further you bring it away, the less you get back in the port. So we find a new way to make some offshore pits and do sand mining in combination. They are not really pits. They are just deepened areas into the sea. You can see it here. This is a soccer field. This is the deepened part of the sea. We deepened an area, then we bring the dredge material, and then the dredger picks up sand in the next pit. It's very efficient. If you bring dredge material, you bring clean sand back to the port, which you can use. But it's more or less like an endless pit. We put it in the pit, because if we would dispose it just like that, too much would come back in the port. Since we put it in the pit, less comes back to the port. But still, it not all at all stays into the pit, so that they're more like they help us. We don't know exactly why. It's research that we need to do. But they're close to the port, so the transport distance is very short. Then we have the slaughter disposal site for contaminated sediments. I said it's huge. Capacity 150 million. The volume is 100 million. High dikes, 1.5 kilometer diameter. And it's just a pit digged into the sea. Sand is used to make the dikes. It's a hydraulic isolation from the surrounding. The sediment is more or less fresh. The surrounding is salt, and the salt water keeps the fresh inside. So contaminant releases are very small. Most important now is the next part of the story, which is the more the philosophy. Looking at solutions, you have to look at a higher level. You have to look at the system. Where does the sediment come from? Where does the sediment go? What does the sediment mean in nature? You have to be aware of those things to be able to make more holistic approaches and real solutions. So we knew that 50% of the sediment which contaminated the port was also contaminated the sea and the estuary, the protected estuaries where people enjoy and do their vacation. So we said maybe we should appeal to that part of the contamination instead of the part in the port to solve the problem. So that's why we had to know this, and that sediment goes to the sea where it belongs. So also relocation we think is a good thing because it contributes to the nature again. But then we had to look at the system as from source to sink, and the water, but as well the sediment. And we studied the River Rhine, and then you see how beautiful it is, where the source is in Switzerland, the border of Austria, Lake Bodensee, the very small falls compared to your country in Schaffhausen. Then where it starts in Basel, the first big city, where the big pharmaceutical industry, chemical industry, but also the sewer treatment plants of the city brought in extreme amounts of contaminants. And I remember 1986 when there was a fire, and the water from the fire came into the river, killed all life in the River Rhine. Since then, there is new legislation for the Rhine. We were already starting our program then. Basel, 700 kilometers upstream. This is Germany, with the locks, with the weirs and the locks upstream the River Rhine. We come to the Netherlands. You see, we also have little hills and cows, of course. There the river starts meandering in the lowlands, goes different directions. You see where the most boats go, that's the direction of Rotterdam. And then we see the river meandering through the city of Rotterdam. The bridge again, the port. This is the last 20 kilometers of the port. It's in total 40 kilometers towards the sea. Then ends up into the sea. But that's not the end of the water. The water, as you saw, is with a coastal river flow going up north to the estuaries and even to Norway and Sweden and Denmark. It feeds nature. It feeds the intertidal areas with sand and the wetlands with mud. And that's what nature does. So that's what helped us to solve the story. We wanted to tackle the sources. So we did source and identification, load assessment, contaminant balances, legal research, information campaigns, dialogues, and agreements. And I was responsible for the technical part of this process. And then we studied the cadmium concentrations in the river, upstream all the way downstream to Rotterdam. We measured with a boat in front of the industries how much they discharged. People didn't like it, but it was allowed to do it. They couldn't forbid it. So we measured how much the industries discharged. And then we confronted industries, this is what you discharged. They didn't like it. At first, they organized an excursion to the sewer treatment plant because they were very proud. They built new sewer treatment plants in the 70s, and there we came and we said, what you do is not good. We said you have to reduce your input 70 to 90%. So the first meeting, we did get no coffee. But things improved. But that's thinking beyond legislation, but thinking with a good message. And if you have the right cause, and you can explain to your parents and they agree, you certainly should do it. So in the end, with not negotiating with stakeholders, but threatening with legal procedures, making figures that we measured known to the public. We didn't so far. We did it like Greenpeace, but we were not like Greenpeace. We made agreements with the chemical industry, with the steel industry, with the pharmaceutical industry, about 70 to 90% reduction. Almost seems unbelievable, but it happened. What the real proof is, of course, in the material itself. Here you see the reduction of contaminants in this dredge material in Port of Rotterdam. Very striking in cadmium, from 14 to less than what I say 2. So 70 to 90%. Not only due to this program, but it certainly helped. I explained to you about the big disaster in Switzerland, which caused the Rhine Action states to make a program. They said we have to reduce 50%. We were there and we said it needs to be 70 to 90. So I think we were right. We knew that it needed to be 70 to 90 because then we could meet our standards for ocean disposal. But again, you can see it same in the dredge material disposal. The red is the contaminated, the yellow is the clean. We solved our problem more or less. But we didn't stop with the industries. We started a program to inform also communities. And later we started the program to look at historical contaminated sediments. They are still there, upstream. We did a study in 2004. We looked at substances of concern, areas of concern, but also areas of risk. When it's covered by sediment, and due to climate change, it would not come freely available, you don't need to worry about it that much. You better leave it in place. But we identified places with evidence of high risk and evidence for risk. And we put it on the agenda of the EU and the Rhine Commission. And in the end, we succeeded in bringing it on their agenda to have sediment management programs. So we had this intensive program, significant improvement. The Slufter, you know, this big disposal site. When you look back at it, it's crazy that we designed it that big. It's 2 times as big. It's only half full, but it's a symbol, I think, of a successful policy. We now use it to solve problems of other ports. Emission control is, of course, essential, and you need a balanced action. Not only a clean river, not only the EU framework, water framework, but also the marine directive, the marine strategy, because it's the sea which sets the standards. So sediment management plans are incorporated at the river basin scale internationally, and they're in focus of SETNet, and that's the last part of my presentation. SETNet is, unlike all the networks mentioned here, more a scientific network, which deals with sediments. It's a European network. It's about 15 years ago. I was there when it was set up with European money. Now it's not anymore European funded, but it's live, very much alive. Still acts today. They have a 9th International SETNet conference in Krakow, in Poland, this month. Solving societal challenges working with sediments. So, and I also brought their brochure for almost everybody, I hope, with their main messages. How much time do I have?
3 minutes.
3 minutes. Well, it's going well. So they say we have to address the issues, put them on the agenda, quality and quantity issues, contribute to the further development, multidisciplinary information point for the European community, but it's available worldwide. I know a lot of US people are participating as well. 4 key messages. One is about the risk and the situation, that sediment quality, and it can remobilize, and it can go into the environment. It's moving toward the basin to the sea. To be aware of that, and it needs integrated basin management plans. It's a fundamental and important component of aquatic ecosystems. That's where the working with nature comes. And so you have to find this sustainable balance also with ecosystem objectives. And also it's linked to the hydromorphology. And in the past, when we made all the locks and dams and hydropower dams, we managed the water, but we forgot about the sediment and certainly about the biota. And now today we find all these problems worldwide with sediment disturbances due to all the man-made structures in rivers. We should learn from that and do it different in future. So this is also a platform that's now dealing with those kind of things. And dredge material, as Harold said, as is in the London Convention, it should be seen as a resource. These are the 4 main messages. The final message to remember, I wanted to inspire you, and the best thing to do is to have some kind of picture. So I went upstream to Basel, and there we talked to the people about our problem, but that the problem also had something to do with them, and in Germany. And we said, you go on vacation to the beautiful estuary, but your enjoyment may be linked to your behavior in your backyard. And then they were really puzzled why that should be a link between their behavior at home and their vacation in the North Sea. And then we could explain that's through the sediment. And the contaminants, they attach to the sediment, and they can go all the way to destroy things in the North Sea. In the 70s, there were a big disaster with high casualties of mammals. Now it's all of the past, but at that time it helped to get the message across. Well, that's it. Thank you very much for your attention.